am Subinay Kumar. I am from IISc Bangalore. So I am going to discuss the ramp response for this transfer function, uh, somewhat by induction. Okay. So see, first of all, for this you know some basics. For example, for this transfer function, s by omega p, the step response will be this. How? First of yeah, you know some concept means like initial value theorem and final value theorem. Initial value theorem is f of s tends to infinity, and final value theorem is f of s and limit s tends to 0. Okay, so see, for this step response will be step response for this transfer function, step response will be whole, and if you apply the initial value theorem, then initial value will be 0 and final value will be 1. Okay, so see here for this transfer function, for this much step response will be this. Okay, after that, if you know this basic, then it will help to derive a ramp response. Response of this transfer function. This transfer function. Ramp response of this transfer function. Okay, so see, this is the step response, and after that when I want the ramp response, then I just integrate to this, and I'll get my ramp response for this transfer function. Okay, and see, this h of s for the ramp response I'll multiply with the 1 by s square. So I'll just from the 1 by s square, I'll take 1 by s, and 1 by s I multiply in the inside term. Okay, so it will become how this is the 1 by s upon 1 plus s by omega p, plus this is s by omega z upon 1 plus s by omega p, and this is s1 by s square. See, here if you see, then this will cut down, and this will become 1 by omega z, 1 by s, and 1 upon 1 plus s by omega p. So this, see, this is look like step response of this transfer function, and it will, the step response of this transfer function is this. Okay, so you directly plot this function, and the magnitude will be 1 by z instead of 1. Okay, so right now I want to calculate this term. So this is the step response of this transfer function. So this transfer function you know directly from here, it will like this. Okay, so if you wrote for this equation, then 1 minus e to the power minus omega p t and ut, this will be the inside for this. Okay, let me clean. So see, for this the time domain function will be this, So if you integrate this for the ramp response, then you will get whole total. Okay, so for this you integrate minus infinity to infinity, this will be 1 minus e to the power minus omega t u of t dt, and you just integrate this, assume this is the first one and this is the second, and you integrate. Okay, so first second integration t minus e to the power minus omega p t omega p, and limit will be minus infinity to t minus integration, and this will delta t for this, and this the see first stop and second integrate, second term integrate, and after that minus, and first term differentiate, and second term will integrate and put the limit, and after that integrate whole. So if you see, no, not put limit put at the end of the integration. So if you integrate this term, then you will get t minus e to the power minus omega p t upon omega p, then and multiplied with the delta t. So if you multiply with the delta t, then it will become 0, and it will become 1 by omega p with positive sign. Okay, so this is the omega p. Okay, so see, now it is u of t, and this is ut minus omega pt and omega p. Put the limit, and then it will become this, and minus this delta t will become u of t by omega p. Okay, so now this is multiply ut inside, so it is omega, something is wrong I think. Okay, this omega p e to the power minus omega p t. Okay, so right now is t ut, so t and 1 by omega p from here, and this is u of t plus e to the power minus omega p t upon omega p. Okay, so this is the ramp response for this transfer function, for this. Okay, 1 by 1 plus s by omega p, and if you plot, then how it will look like? With plot, then how it will look like? See, if you plot this, then it will look like, see, at t is equals to 0, it will become 1 by omega p, omega will gone, and it is t. See, this is the input t of ut for this transfer function. For this transfer function, I plot the ramp response. Okay, for this transfer function, I plot the ramp response, and this axis is t. See, if at t is equals to 0, it is look like this one. At t is equals to infinity, this term will get 0, and this term only remaining. See, then at t is equals to infinity, it will look like this. T is equals to infinity, and for the very less t is e to the power minus at v1 minus a of t, then this. Okay, so for the very less, this will in the function, so they will decrease, like, because at t equals to 0, it is 0, and see, and at the infinity, this is become will how much? 1 by omega p. So for the transfer function which have only one pole, the ramp response will be look like this. Okay. And if you want to plot the total response for this transfer function, then you add the response for this. So add the response for this is, instead of 1 it is omega z. Okay, you just add both the plots and you get the total ramp response for this transfer function. Thank you. So see, if you add both, then for this transfer function, this was the ramp response. So for this time domain equation is this t minus 1 upon omega p ut plus e to the power minus omega p t upon omega p into u of t. And for this transfer function, the ramp response, the step response is this, and no, for this transfer function, if you want the ramp response, then it will look like this transfer function will become this, and this is look like exactly the step response of this, and step response of this is here. Step response of this means this, for this transfer function, ramp response is look like the step response of this transfer function. So you know directly the step response for this transfer function is this. Okay, so you add both these and you will get ramp response for the whole transfer function. So if you add, then see, after addition you will get this term t minus 1 by omega p minus 1 by omega z into u of t plus this, and if you plot, then you will get this plot, and what is the difference between this is omega p 1 by omega p minus 1 by omega z. How? At t is equals to infinity or t very greater than 1 by tau, so t very greater than 1 by omega p, otherwise minus omega p t very less than 1, then sorry, for t tends to infinity, this term will get 0 and you will remain with this term, and this term is look like t minus k some constant, and this is function, so means difference is minus k only. So you can see directly this is the input ramp and this is the output plot. So for the ramp, for this whole transfer function, the ramp response will be 1 by omega p minus 1 by omega z difference, and they look like that. Means this means, so see, it is look like the only one. See, this is look like the, if you don't know what is, means if you don't know what is the difference between this, then you just see and compare in both. So you will get to know like this is the response, the ramp response of this transfer function only. If you don't know what was the transfer function, then, because see here this is not mentioned. If I mention 1 over omega p only, the difference, then means addition of 0 gives some